Safe by Design was hastily recorded in front of a live training room audience.
We are going to be playing roles, so what that means is, the roles that we're in, we might have to break out of them to answer questions as they come up, right?
You guys, if you have any questions while we're kind of playing this little nice skit, doing this skit, then please stop us and we'll figure it out and hopefully be able to answer it. All right, so I guess I am the manufacturing engineer and I've got some problems with my parts that I'm shipping to my customers. They are threatened to cancel orders because there's just 4 problems that I'm having to deal with on this plate. The first problem is that we have inaccurate shipping weights. So we're getting penalized with our shipping. And so somehow we got to figure out how to take care of that. We also have dust and contaminants, things like that, that's actually happening, that's actually occurring on the plate, and it's not getting wiped off before we actually place them in the shipping containers and put them in the boxes, so customers are getting dirty, nasty parts, not a really good thing. The third problem that we're actually happening, oh, you guys can read this as well as I can say it. So anyway, is that there is supposed to be a barcode. What do we call that, Michael?
2D barcode.
2D barcode.
Data matrix.
Data matrix. That's going to get the right terminology. It's supposed to be there, and a lot of times it's not there, or it's illegible, it can't be read. So that's a third problem. And then lastly, the cutouts. Sometimes they're not quite correct. They're not within specification of where they're supposed to be. And we need a way to figure out basically how we can identify that and then stop sending customers bad parts so we can continue to ship them good parts, right? So without further ado, I'm calling in my local ES&E specialist to help me solve some of these problems. Maybe we can put this together as a package and come up with some kind of design, right? Michael Parker, my automation specialist from Electric Supply and Equipment. How you doing, Michael?
I'm all right. How are you?
Good to see you today, man.
Good to see you.
Thanks for coming in and helping me out. So just real quick run through. We got inaccurate shipping weights. We got contaminated parts. We've got illegible barcodes, and we've got cutouts that are missing.
Yeah, it sounds like you got a few problems.
Yeah, so what can we do about the shipping weight? Tell me how we can fix this.
So how about a standard weigh cell? Would that probably solve your problems and give you accurate readings on your plates?
Yeah, absolutely. No, so like we've got just a scale sitting there. We're going to have the operator put the plate there, and then he's going to write down the weight.
How about a integrated system that we can send all that data back to? Some type of control system.
So the control system is going to be able to get the weight.
It will, and you're right, the operator placed the plate on the weigh cell, and then we'll get some type of visual feedback.
Okay.
Let him know if it's correct.
So like a HMI or a stack light or something along those lines?
Yeah, whatever you choose, or we can do both.
All right, so it'll know if it'll be a fail or a pass or whatever the case may be.
Obviously, you can get green for pass
and
red for fail.
Awesome. Well, that sounds good. Well, what about this contamination issue we're having on this plate before we ship it? How are we going to take care of that?
You're in a dirty environment, it gets a little dusty. So before the plate gets to the barcode reader, how about some type of automated brush or some type of cleaning system?
Yeah, cleaning system's good. Maybe like a car wash cleaning or something like that?
Yeah, some type of brush. It'll be automated and it'll clean the plate and make sure it's nice and clean before it arrives to the camera or the barcode reader.
That sounds like a plan. Absolutely. Sounds good. Yeah,
there
you go.
Some type of brush like that.
It's like a car wash brush.
All right.
All right, so the barcode, really, really important. Customers are upset. We're shipping them illegible. We're shipping them so that they don't even have them, and customers are really upset about this. So how can we verify that we've got the barcode reader? You guys can see it as well as I can. Michael's getting ready to talk about this.
What about some type of machine vision camera? How about that?
That's great. Machine vision would be good.
Yep,
would be really good.
The machine vision camera can not only will read your barcode, but it can send your data back to the control system, but it can make sure that the barcode's correct in the right place on your cutout, on your plate.
And once again, this is something that we're going to get operator feedback, and it's going to say pass or fail, all that kind of good stuff.
Green light, red light.
Okay.
So,
all right. Well, cool. All right, so I guess the last problem, and I don't know, this sounds a little bit like a challenge. I have to verify that all of these cutouts are actually in the right place before I ship them out to customers, and that's not being done right now. So how can we solve that issue?
So we've got a type of 3D sensor that we think that can solve that problem. How does that sound to you?
That sounds good. So it actually, it just takes an image of you teach it or something
Yeah,
like that?
you can teach it. You can customize your shapes. You can verify the cutouts are there. We'll take some measurements on them. It'll send the data back to your control system, and then you'll get some type of visual feedback.
That's awesome, man. That sounds really, really good. I like that. So, have you had any time to think about how this machine might actually work?
Yeah. I
Maybe
think
it's like a sequence of operation. I know that's like, you guys know, everybody has built machines in here, but you got to start with the sequence of operation, right? That's the first thing that you got to do when you're building machinery, right? So let's talk about a sequence of operation, Michael.
So you want to go through a sequence of operations, just start at the beginning and go all the way to the end? All right. Okay. So to start with, operator, you want to weigh the plate to make sure it's correct. Is that right?
So he's putting it on the
so we'll
scale.
get an operator and we'll put it on the scale. We'll weigh it. It'll verify the weight. It'll give you some type of visual feedback, yes or no.
Okay. All right. Well, after that, we know we either put it in the bad pile or the good pile. And so then what do you think happens next?
Yeah, so once we get verification on the plate, if it's passed the weight or not, then we'll load the plate onto the conveyor.
Oh, so we're going to have a conveyor with this.
Yep, so this will be a manual operation. You'll take the plate off the weigh scale and then place it on the conveyor.
Place it on the conveyor.
Yep.
Okay. All right.
So,
Sounds good.
yep, once the plate is placed on the conveyor, we'll have a photoelectric sensor. This will just verify that the plate's on there and it's ready to go, because you don't want the conveyor running without a plate on there.
Right. Gotcha. Okay. All right. That sounds good.
Once the photo eye detects the plate, the plate will then take off down the conveyor. Then that's when it'll pass under your automated brush to clean it off.
Okay.
Get all the dust and particles off of it. Then once the plate is clean, it'll go under your barcode reader. It'll stop in the same place every time. We'll be using this servo. We'll make sure it's in the correct spot every time. Then when it comes to a stop, we'll take a picture of the barcode, verify the data, send it back to your control system.
Now, you say it's going to stop in the same place every time, but I know that conveyor motors, they can get slack in them, all that good stuff. So how do we make sure that the plate's going to be able to stop exactly in the right place so it positions itself where the camera's supposed to be and can actually
we'll
read it?
use a servo.
Oh,
we'll use that.
Use a servo motor on the conveyor.
Yeah, that's right. That's right. So that way we know that it will come to the same exact spot every time.
Okay. All right. Well, that sounds like a plan. Well, what do we got? Okay.
So we then after you read your barcode, the next step will be to verify that the cutouts are there. This will be done by our 3D sensor.
All right.
This also will send that information back to your control system.
Nice. Okay.
Last thing, so then it will move to the end. If it's made it all the way to the end, we know that it's passed. Our last photo sensor will verify the plate is there. Once the plate's there, then the operator will take the plate off. If it's made it all the way to the end, then we know it's a good plate. You can put it in your good stack and send it out the door.
Nice. Man, this sounds like a really good sequence of operation. Maybe
right,
going to take
well, good,
care of all four of my problems, all that good stuff. I know I've asked you to come up with this on the fly real fast and everything, but man, is there any way, like, do you have like maybe an image or something of what you think this machine might actually
so
look
maybe
like?
Maybe an image or some type of virtual machine.
Virtual
that you could
machine.
look at and
Yeah, okay.
so-
Whoa, right there.
Yeah, so
all right.
we've got a really
Amazing.
great design
Absolutely
engineer
amazing.
that can do all types of stuff.
Wow, that is amazing. Look at that. So, Michael,
Yeah, how's this machine look for you? How does it look?
looks beautiful. It looks beautiful. Can we talk a little bit about maybe some of the technology that we're going to use?
What do you think about integrating and using IO-Link technology on your machine?
I have no idea what I
No idea?
No idea.
Well,
what
IO-Link
is.
technology, it's an open serial communication that's going to allow your sensors and actuators to provide enhanced data on your machine.
Nice. And so it looks like it's maybe just a single cable that comes from each input device that's out there, each instrument, and goes back to a
Yeah, that's
a
correct.
block.
That's correct. So we actually have two different options for your IO-Link master. We have an on machine, and an in cabinet, but I think for the type of machine you're wanting, I think the on machine will probably be the best option. What do you think?
Yeah, for sure, because we probably won't have a lot of cabinet space and all that good stuff.
Yep, so down here at the bottom, this is where your power will be, but you can see you have an Ethernet cable going back to your compact Logits and a panel view.
Nice.
And these, so your sensors will be your smart devices. This is what's going to relay the data back to the armor block.
Interesting, interesting. Can you tell me a little bit more about the sensors maybe?
Yeah, so the sensors are going to be our smart devices. With IO-Link, each type of sensor has its own IO-Link features. For example, a photoelectric sensor will have different features than a prox sensor. That'll have different features than a distance measurement sensor or a color sensor. So every type of sensor has its own different features. With these features, you can kind of customize them to whatever type of application you may be doing.
Okay, all right.
And you've probably seen, have you ever seen this symbol on any of your sensors that you have been using right now?
Maybe, doesn't ring a
Yeah,
bell
so
right
that's
now.
just the IO-Link symbol. So you could be using IO-Link sensors now and not even know it or not even getting the features out of it because you don't have this armor block or...
Well, they're probably going to cost more, I'm guessing, if they can communicate on the
No,
network.
they don't. They are the same exact
What?
price.
No
They're the same
way.
price.
Come on,
They
man.
are. They're the same.
IO-Link sensors are the same price?
The same exact price.
That's insane, man. Okay, well, I get all this extra stuff. It looks like it's going to save me on wiring. Do you have like a specific example, maybe of like the photo eye cutout?
Yeah, so
On here?
yeah, so at the beginning we talked about your operator would be placing the photo eye on the conveyor. The photo eye will detect if the plate's there or not. So I noticed, is that a stainless steel?
It is stainless,
plate?
yes,
So you
it's
know
stainless.
is very bright.
Right.
Any type of light or cameras or photo eyes, the light shines back into the lens. It makes it hard for it to even recognize if it's there or not.
Gotcha. Okay.
So one of the things I was thinking we could use would be signal strength.
Okay.
So you can go in manually and adjust the signal strength of your photoelectric sensor to determine the ranges of it that will give you a pass or fail when the plate's placed down on the conveyor.
Now, I remember there's a little pot. You could open up the photo eye and kind of turn the pot in order to adjust the sensitivity of it, but that's not what we're talking
No,
about
you
here.
can actually get a raw number value on this, and you can go in and manually set it to whatever type of plate, whether it be stainless or whatever you're running, but this is manually adjustable.
Okay, all right.
Another feature too, I know you said you're in a dirty environment, so we do have a margin alarm, so you can set that as well. If your photo eye is getting dirty, you can get an alert to say, hey, come over here, wipe me off, clean me off before the machine shuts down. Does this sound like something that could be on the
That
machine?
definitely sounds like the plan. Sounds like some DeviceNet stuff from 25 years ago, doesn't it, Jeff? Sorry, just had to paint that.
So it's got a lot of cool features, but that's probably the two that we'll focus on, Reggie. Okay.
That sounds really cool.
So visual feedback, we were talking about that as well. What about the stack light? You know, stack light has, we have an IO-Link stack light. Did you know that?
No, I did not. And we get all these lovely colors, all that.
They do.
Okay,
Yeah,
that's pretty
so
cool.
Yeah, up to 7 stack lights.
All right.
7 different, so that's going to save on wiring as well. Also allow you more import-output ports.
Yeah, because I mean, if it's just a single cable to the base of that thing versus, you know, I don't know if we'd have 7 or whatever, but yeah, that would be a tremendous savings. I
Yeah,
could
so
see
you can
that.
here's a few cool features you can do. You can get some vibration indication, things like that. Also, too, did you know that you can have kind of a customizable voice recording?
Oh, are you serious? So I can say, like, wake up, don't fall asleep on the job kind of thing?
You can.
To my operators?
Yeah, and you can have
Yeah.
7. You can have 7 of those as well.
Okay. Well, that sounds good, man. I like that. A customized module I can record myself. Yeah, voice module. Nice. Okay. All right. Well, that sounds good. Definitely stack light. That sounds good. What else you got for me, Michael?
So what about a distance measurement sensor? You know, if we use one of these, you can know exactly where the plate's at on the conveyor at all times.
Right. We'll probably know that for the servo, but maybe we could use this as maybe like a homing.
You can.
Could use this as a home position, maybe.
I think that'd be a great idea.
Yeah.
And the thing about that too, the DMS, you're actually going to get the distance back in millimeters. You're going to be able to see this raw number. So you're not going to have to convert this number or scale it or anything. You're actually going to see the number
In
the
millimeters.
distance. In millimeters.
So what's my span? What's the max I can go
Well,
with
you can
this?
go up to 5 meters.
Wow. Millimeter accuracy within 5 meters. That's right. That is amazing. Okay. All right. Very cool.
So the first thing we talked about was the load cell. So we've got a brand new load cell, and it actually has IO-Link technology as well. And one great thing about this is the PLC connectivity, it's already integrated into the load cell. So you don't have to have no additional device is required.
So my experience with load cells is you could have one or have a number of them, and then you have to take it into a summing box. And then from the summing box, you have to go out to a specialized module inside the PLC. It could be a weigh scale module. We've probably all heard of that before, but now what you're telling me, let me see if I can get this straight, is that I plug this into my IO-Link master.
That's right.
And that's it.
That's it.
It just shows up.
It does. Nothing else is required on your end.
Wow. Wow. And this is brand new?
It is. It's brand new.
Wow. That is amazing.
I think that'd be
That's
pretty
really
cool on your machine.
Yeah, I think that's definitely for weighing the application right there on the machine for sure. That will definitely do it. Cool. All right.
Well, you want to do one more type of visual feedback for your
Yeah,
operator?
yeah. Let's talk about that.
So what about a panel view 5000? What do you think?
That works for me. I mean, that seems like a pretty good HMI. I've heard some good things about it. So yeah.
Did you know did you know it has advanced diagnostics? Did you know that?
Did not know about the automatic
so
diagnostics.
the one cool thing about that is anything that's hooked up and connected to your control system, if something goes wrong with the device on it, power failure, cable unhooked or cut in half, did you know you'll automatically get an alert sent to your panel view saying what's wrong with it and what device it happened?
Yeah, but I got to program it, right? I mean, we've had diagnostics for years, so yes.
No program is required.
Oh.
It's automatically embedded. It happens for you, so you don't have to do anything else on your end.
You're kidding.
Nope.
No programming for diagnostics.
No programming at
It
all.
just shows up.
It does.
You're going to have to show me that, man.
Okay, well.
Definitely going to have to show me that.
We'll see it later.
All right, I'm going to have to challenge you on that. I've always had to program my own diagnostics, right? And you're telling me it's just going to show up. That's crazy. That's crazy.
So getting off of IO-Link, this will be connected via Ethernet, going back to your control system. But yeah, so a Cognet or any type of machine vision camera, this will be reading your barcode, detecting that the data coming out is correct, making sure it's in the right spot on your plate. You know, it's got all different types of tools and stuff we can add on.
Nice. Okay.
Yeah.
All right.
Yeah.
So no issue reading this really small barcode.
Nope, not at all. You can read any kind of barcode you can think of.
Okay. All right. That works. That's good.
And at the last step was your cutouts, right?
Yeah, the cutouts are not.
Yeah, so this is a 3D sensor. It's actually an Allen Bradley 3D sensor.
Okay.
So this is going to be used to verify the cutouts are there, make sure they're the correct shape. Since it's an Allen Bradley as well, it's easily integratable to the Allen Bradley PLCs.
Okay. Well, good. So it just shows up as another device that's in the tree there.
It does.
Okay.
Yeah, and you can
All
have
right.
all types of shapes and different templates and everything like that. I think it'd be good for your application.
Okay. All right. That sounds good. Well, this sounds great. What else you got for me, Michael?
Well, I think on my end, I believe that's it. Yeah, I know you got a few manual operations.
Yeah.
You got a few, have a few people placing plates.
So I can't afford a robot. I know we said we were going to put it on a weigh station and then maybe have to take it and put it on a conveyor, and no money for a robot at this point. So
Not in your budget.
not in the budget right now, for sure. So what would you suggest as far as just basically protecting my employees
Well, yeah, I
from
was
getting
gonna
hurt
say,
when they're using this inspection system?
What about, I think safety devices? That'd probably be a good idea for you to have some of that on your
All
machine.
right, so yeah, I think it'd be a good time to talk about safety devices for sure.
What about my counterpart, our safety expert? What about
Bring him
Kevin
in.
York?
Bring him
Would you
in,
like to
man.
talk to him?
Absolutely. I want to talk to him. Have him educate me.
All right.